All right, so I wanted to give y'all a few more examples on quadratic applications. Um, projectile motion is the one I feel like most people struggle on. So this example is from your notes. This is example number 47. And this is basically about an astronaut on the, he is, well, it doesn't say where is he at? Oh, on the moon, He's on the moon playing baseball, all right? And it gives us an equation to model this, and it says S, all right? So the height of the ball, S, is given by negative 2.7 t squared plus 30 t, and then plus 6.5. All right, so a couple things to talk about first. Now, this is projectile motion, meaning this right here has to do with gravity, and normally it's, the gravity of the Earth. We're normally dealing with like negative 16 point something. I forget what it is, but maybe 16.8, 9.8, something like that. But here we're talking about the gravity of moon, so gravity of moon. All right, and then we have our initial velocity. Right, the initial velocity, that's how fast the ball is going when he first throws it. It tells you this in the problem, right, 30 feet per second. And then we have the initial height. All right, it's important to know this because the equation might not always be set up for you. You might just be given the information and you're expected to kind of know a little bit like, hey, the ball's going 30 feet per second. Well, you know that's the initial velocity. It's going to slow down as gravity's pulling it, right? Pulling it to a stop, right? How tall? It says that the astronaut's 6.5 foot tall, so 6.5, right? But that's just, there we have that. Move that out of the way, now you know. All right, so what's the question asking us? After how many seconds would the ball be 12 foot above the moon's surface? All right, 12 foot above the moon's surface. So after how long is the ball? So like we want the time when the ball is 12 foot off the moon's surface. It literally just threw it. So I'm gonna go 50 foot just to make it a little further. But let's think about this, right? So let's think about this for a second on a graph, right? It starts off, this dude's 6.5 feet tall. So it starts off about 6.5 feet tall, and then he's throwing it. And although it's not Earth, there is still gravity, so it's still gonna go up and then come back down, right? There might not be as much gravity, but there's still gravity for a mass. So the ball is going up. Let me, probably not like that, but let's see, it's gonna go up, and then after some amount of time it's gonna come back down, right? And it's at this point the height would be 0, but I'm looking for this, and I'm hoping that the ball actually goes this high, right? I'm imagining it does if he throws it at 30 feet per second, but I'm imagining there's going to be two answers, right? Two answers, because there's usually one going up and then one going down. Now, in the rare occasion that wherever you're doing your line is right at the vertex, right there, then you would only have one answer, right? And then it's also a possibility that you get none of the answers, meaning the ball wouldn't go that high, and we can talk about that as well. So I'll just show you this one. I'm assuming that the ball will go 50 feet, but if it won't, we'll figure it out in the problem when we're doing the math. So let's think about this. We want the time, right? We're looking for t. We're looking for t when the ball's height, right? With the ball's height is 50. And we know that in the problem it tells us, S, the height S of the ball. So a lot of people look at the problem and they're like, I don't understand. Read it over and over and until you do understand, right? So S is the height. So I'm saying 50 is equal to negative 2.7 t squared plus 30t plus 6.5, and I want to solve for t. Now, when I start doing problems like this, a lot of the time when they're talking about time, I'm not going to mess around with trying to factor. I'm not going to mess around with completing the square. All right, there's really three techniques that you should be using. I mean, you could say the square root, that's a fourth technique, but that wouldn't apply here anyway. There's really three techniques that you could go about to try to answer this problem: factoring, completing the square, and then quadratic formula. You should know all of those. If you don't know those techniques, then you need to go back and watch a different video. But for this video, we're just trying to, apply this or solve this, and we're going to apply one of those techniques. And when I see a bunch of decimals, when I see like time, because I know time usually doesn't work out perfectly, it's probably unlikely that this is going to result in an answer that's like right on the dot, like 5. After 5, it's probably going to be some weird decimal, right? I don't know what it is, but there's more than likely there's going to be 2 answers, and both of them are going to be weird decimals. So in this case, I'm going to use quadratic formula, right? So check that out if you don't know the song for quadratic formula. But before you start on the quadratic formula, you need to get this thing you need to get your equation with A, B, and C. That means you got to get it set equal to 0. So subtract 50 on both sides, and you got 0 is equal to negative 2.7 t squared plus 30t minus 6.5 minus 50, we got 43.5. I should be able to do that in my head, but you don't want to chance it. All right, so we're saying A is equal to this, right? Not the t, but just the coefficient. We're not worried about the variable. B is 30, and then C is that, right? And we're saying our answer, or t, I guess, in this situation, right, time is equal to negative b, so negative 30, right? When we're putting in our answers, we should always, or when we're substituting in, you should always use parentheses just to play it safe. Plus or minus the square root of 30 squared. You don't have to, but I find people make mistakes when they don't, so just do it. Minus 4 times a, which is negative 2.7, times c, which is negative 43.5, right? All over 2 times a, which is negative 2.7. And now I'm going to put this in my calculator, right? I don't think the answer is going to be imaginary. If the answer could be imaginary, then that'd be a different thing. But if I throw a ball, then it's going to, and it gets to 50 feet in the air, then it's going to be some real amount of time. When you're putting it in your calculator, you got a TI-84, hit that green button and then hit y equals and enter and create that nice fraction bar. And then I'm writing negative 30 plus the square root of, I'm not trying to simplify things and have an opportunity to make a mistake. I'm just going to put it in the calculator and pay close attention what I'm doing there. So minus 4 times negative 2.7 times negative 43.5, all in parentheses, just how I have it written, times, or all over 2 times negative 2.7, and we got one answer, right? When I hit the plus, right, the plus, there's a plus one, right, because we got 2 answers here. The plus version gives me 1.71458, 08. It's going to keep going, right? And then there's the minus one. So I'm going to scroll back up, capture that same expression, and I'm going to change the sign right in front of the square root to minus. And then I get 9.3965 302. So we're talking about time. So I mean, how exact do you want to get? I'd say like 1 decimal place is fine. If you're not sure, go 3 decimal places, and you're usually good. So I'm gonna, since we're talking about time, I'm gonna say 1.7 seconds, and then I'll say this is 9.4 seconds, right? So that's when it's 50 feet above the ground on both of those. Let's see, do I got some more time? How many seconds will it take for the ball to hit the moon's surface? So, how many seconds will it take for the ball to hit the moon's surface? Well, here's the moon's surface. How many seconds does it take the ball to just have a height of 0, right? So this is kind of another question altogether. So where is the height 0? 0 is equal to negative 2.7 t squared plus 30t plus 6.5, right? We're going back to the original equation, and then we're just setting it equal to 0 because that's the height when the ball is on the surface of the moon. And now you're just applying the same thing. We're going to do the same thing, but now A, B, and C are a little bit different. I'll leave you to that. There ain't no need for that. It says, problem number 48 says, the ball in this problem will never reach a height of 100 feet. How can this be determined algebraically? So it tells us it's never going to reach 100 feet, but how could we determine this? Well, we can try to solve it. We can set it equal to 100 feet and say that's negative 2.7 t squared plus 30t plus 6.5, right? And we can try to solve it. So first, subtract 100 on both sides. We got 0 is equal to negative 2.7 t squared plus 30t minus 93.5, right? And then we can use the quadratic formula once again. So I'm going to write it out and say, okay, my time is equal to negative b, so negative 30, put parentheses, plus or minus the square root of 30 squared minus 4 times a, which is negative 2.7, times c, which is negative 93.5, all over 2 times negative 2.7, right? And then I'm putting that in my calculator. All right, so alpha, y equals enter, negative 30, plus this time the square root symbol, and I'm saying 30 squared. Remember, if you had a negative and you didn't put it in parentheses, then you would be wrong, right? If it was negative 30 squared and you just said negative 30 squared without parentheses, you'd get it wrong. So if you don't put parentheses, that's fine, but you just need to know what you're doing. And there's a good number of people that jump on the calculator and they don't know what they're doing. So then they don't know why they're wrong. Gotta think. This thing can't think for you. All right, so you type it in exactly how you have it, right? You're careful. And now it says, maybe it says error. Maybe it says non-real answer. Mine says error, non-real answer, right? Now, maybe I made some mistakes, so maybe I should check it again. But when I didn't make a mistake, and I checked that just tells me that my ball, it never reached that height. It never reached the height of 100 feet off the ground. And that's how we can determine it algebraically, because you can't get a solution to it. Well, I can't say how much time goes by before this ball becomes 100 feet off the ground. If it never came 100 feet off the ground, there wouldn't be an answer, or the answer wouldn't be real. Hope this is helpful to you. Have a great day.